Good morning, everybody. First of all, we would like to thank the organizing committee for giving us the opportunity to deliver this speech on inference control techniques in AI image generation for architectural design visualization. So, generative AI-based techniques are an emerging paradigm in architecture. And this implies new ways of conceiving and representing architectural space and also redefining the boundaries between designers and tools. The crucial aspect in these boundaries is the possibility to use control parameter to effectively control the generative process. So next, please. The aim of our research is to understand the potentialities and limitations of AI image generation technologies in the field of architectural design, as this is already influencing the design and representation processes. And our main objective is to develop a flexible methodology capable of integrating the different inference conditioning parameters to verify the efficacy of control that the user can have on the generative process, and this could lead to a more effectively integration of these tools in architectural practice. Next, please. We started from a brief review of the state of the art, and we defined some categories of use of AI in architecture and construction. And we decided to focus on the design creation and visualization of concepts. And we also identified 4 main analysis parameters, which are data computation, source code accessibility, user interface, and AI model type. We decided to focus on local computing for data computation, open source codes, and generative models as AI model type using customizable web user interfaces. Next, please. We also defined 3 key aspects defining our methodology. First of all, we decided to develop several workflows, one for each different conditioning technique in the process. And to obtain these workflows, we decided to use ConfUI, which is a web interface working with VPL, Visual Programming Language nodes. So it's highly customizable. And second, we decided to use a single diffusion model to make results comparable. And the model we identified is Flux1 in its dev version, as it has a great balance between flexibility, quality, and speed. And third, we decided to use a multi-scale approach to verify the effectiveness and versatility of inference conditioning techniques at different scales of representation. So object, interior, urban architecture, master plan, and landscape.
So, this diagram presents a streamlined approach to generating architectural design using generative AI. As already said, mainly focusing on Flux1, the dev version of the diffusion model family. Diffusion models are generative models that excel at creating realistic images from random latent noise. And the diagram also highlights various inference conditioning techniques, from simple image-to-image workflows to advanced model fine-tuning techniques that we will see in a few minutes. And for each technique, tests were conducted for each identified case study for an iterative multi-scale approach. So we have the object, the interior design, the urban architecture, master plan design, and also landscape design. So let's dive deeper into the inference conditioning techniques under study. We can start with the reference image that is a relevant parameter for conditioning inference. This technique makes it possible to guide architectural style, define spatial composition, establish consistent color palettes, and also influence lighting and overall atmosphere, as shown in the pictures. It's important to use high-quality reference images and highly representative of the desired style. The ability to weight the influence of the reference image allows relatively precise calibration of the generative process. And the output is comparable to a LoRa conditioning that we will see later. LoRa is a low rank adaptation, is a way of fine-tuning models, but is not as effective as a LoRa conditioning. Also, a data set of reference image can be used as multiple inputs. Let's go on with the next condition techniques. That's very interesting. The ControlNet is a powerful visual control tool with high accuracy in generating architectural images. The research here focuses on three applications of three types of control maps. So we have the depth estimation that maintains spatial consistency and architectural proportion, the edge detection that's aimed at preserving architectural structure and detail, and that's very effective. Soft edge detection that preserves the overall visual structure of the image. Also here it's possible to weigh the influence of the generated map, and handmade drawing can also be used as input, and that's very interesting, of course. Currently, map conditioning cannot be overlaid as is done in Andes model. For instance, in Stable Diffusion family model, we can overlay the effects of depth estimation and edge detection, but for now, with the Flux model, is not possible to do this, but we are quite confident that this will be fixed very, very soon. Next technique is the large language models. Integrating LLMs into the prompt engineering process represents a significant step, especially for Flux One, which is trained for natural language. In particular, here we was using Mistral 7 billion model that is developed by Mistral AI, and the workflow also uses the Surge LLM nodes. That's a prompt generator or prompt improvement node for ConfUI, utilizing the power of an LLM to turn a provided text-to-image prompt into a more detailed and improved prompt. And under every image, you have the small prompt we give to the LLM elaboration. Some LLM models could also be used for image-to-text operation to extract detailed description of reference image. Other systems, such as Stable Cascade, use LLMs for a step-based cascading prompts process. Next techniques is the inpainting that is extremely useful for partial image editing and refinement, whether the image has been generated or is real, can be also a photo. In correcting and refining specific details, consistency with the surrounding context is maintained. Therefore, context-aware blending becomes essential to assure smooth transition between the original and the modified areas. In the experimentation presented here, as you can see, the mask was the masked areas were selected manually, but there are advanced techniques that allow semantic segmentation of the image. For instance, segment anything 2 is a very interesting foundation model for interactive instant segmentation in images, but also in video, and is open source and released by Meta researchers. Different from the inpainting, the outpainting is extremely useful for image expansion. It's a consistent expansion that preserves the style and scale of the representation. Again, also here, the concept of context-aware blending is essential to achieve convincing results. Depending on the amount of image expansion, two strategies can be exploited. If the expansion is small and there is no need for particular additional elements, as in the cases presented here, the prompt can be generated by a model that automatically tags images with relevant metadata, and we also pointed out the model we used. While for larger generation, the process can be driven by a human-written prompt to add any specific desired details. So we basically bypass the node that automatically tag the images. Last techniques that's very interesting techniques, the fine-tunings. There are many techniques for fine-tuning diffusion models. Low-ranking adaptation that we already talked earlier is an efficient technique to fit a model by changing only a small part of its parameters from a small data set of images without changing the original pre-trained model weights. The Dreamboat is a much heavy computational cost. The diffusion model is improved and trained to generate images of a specific object or person from a larger data set of images. And textual inversion, that's very interesting because a new token is trained to represent a specific concept, such as an art style, an object, a person, and so on. And this is done by associating it with an image dataset that we provide to the model. The Flux LoRa collection developed by X Labs AI was used here in the generation that you can see. And the image uses in order no LoRa and then the 5 LoRa that we tested from the Flux LoRa collection. That it's open source too. So let's have some reflection about what we saw in terms of the opportunities. We can instantly generate multiple design variations, allowing exploring various options very quickly. Professional client communication may be enhanced through near real-time realistic visualization, and contextual analysis enables instant visual integration of new design into existing environments. Conceptual exploration is made easier with the rapid presentation of abstract ideas, and workflow optimization drastically reduce modeling and rendering time, making the design process more efficient. But about the limitation, instead, critical understanding requires deep knowledge of conditioning techniques to achieve optimal results. The quality of the training data is critical. The tile preservation as maintaining specific architectural detail is highly challenging, and proper scale is another common issue. And last but not least, computational efficiency requires large storage spaces and high performance graphic processing units. Future steps include the development of a comparative synoptic table to evaluate the effectiveness of individual techniques, implementing the workflow with XR technologies, and also fine-tuning customized LoRa's, aimed at deepening different aspects like recurring architectural elements, site-specific content, and specific architectural style. Right now, a single workflow that combines the individual techniques analysis under development. And this is as show, clustering may activate individual parts depending on the desired output to increase flexibilities, have meticulous control, and improve computational efficiency. To conclude, a critical approach is essential as AI is a powerful tool that requires in-depth understanding and informed use. Adaptive integration is essential, and collaboration is a key element in the open source approach we had. Continuous innovation is necessary as the field rapidly evolves and requires constant updates and experimentation. Open source models are very important for their adaptability. The transformation of the creative process involves accelerating the conceptual and iterative phases. We have also the democratization and accessibility of visualization that enables high-quality representation for both professional firms, but also for non-expert users. The evolution of professional skill demands continuous education in AI and related technologies. And that's also why new professional roles are emerging. And lastly, ethics and authenticity are critical consideration as we reflect on intellectual property and design authenticity in the generative AI era. Thanks for your attention.